This is 7.2 addition and subtraction formulas. Again, you may want to pause the video to notice these different types of formulas. So you have the addition and subtraction formulas. So formulas for sine. So note, you're going to be using these a lot, by the way. So sine of two things added together is literally this right here. And then two things subtracted together would be that. So again, you're going to be using this a lot. And these are examples of, if they're degree angles, it'd be like 30 plus 10. So this would be like 40 degrees or something like that altogether, but 30 plus 10. And you would just evaluate it by using the formulas for sine. And the same thing with the formulas for cosine and the formulas for tangent. So these, again, are addition and subtraction formulas. So notice I'm adding two angles together, or radians, and then the same thing with subtraction. So again, let's actually use them. So let's go to cosine of 75 degrees. So if I had cosine of 70, so what you automatically ought to think of is, think of the unit circle, think of all, or the common triangles that you're aware of. And what you're going to do is take 75, cosine of 75 degrees, think of it as two angles added together or subtracted together that you might actually know. Well, I think of cosine of 75 as the same thing as 45 plus 30. So cosine of 45 plus 30. And if you notice the addition, so this is an addition formula for the cosine. And again, if you go back to cosine of addition, so that's really cosine, cosine, sine, sine of the two different angles. So notice this first angle, this first angle. So if I go over here, cosine of 45 times cosine of 30, subtract, again, I'm just following the formula, notice what it says, and I'm going to minus sine of the two angles. So sine of 45, sine of 30. And then you're just going to evaluate these. So notice cosine of 45, if you notice the cosine of 45 is square root over 2, and then notice this is being multiplied by cosine of 30. And by the way, I want the exact value. So the cosine of 30 is the square root of 3 over 2, which this is going to give us the square root of 6 over 4. Sine of 45 is square root of 2 over 2, and the sine of 30 degrees is 1/2. So this is going to give us the square root of 2 over 4, and which that's going to give us, because now they have a common denominator, so the square root of 6 minus the square root of 2. So notice that's my exact answer for the cosine of 45. Well, similarly, we're going to do the same thing with cosine of pi over 12. So I'm going to erase this, and we're going to do cosine pi over 12. And what we want to do is basically think of two things that can be added together or subtracted together that will give me common radian measurements. And we normally know like a 30, 60, 45, those are the degree measurements. So the same thing with the pi's, what we're going to do is try to add those together or subtract them together. That will give us this. Now think of one way to do this. If you prefer degrees, you could literally change that to like 15 degrees and then do the exact same thing. And you could literally just, think of it as like 45 minus 30 degrees is how I would get 15 degrees. Okay, so we're going to literally do that. But again, we're going to do it in radian mode. So this is literally cosine pi minus 45 minus the 30. And so now, again, cosine pi over 12 is the same thing as this right here. And then we're going to use that formula again. So cosine pi over 4. And again, we're using the subtraction one. So this is the adding of these two together. And then you just evaluate them because we want exact answers to be able to do that. And you can see I can work it out very similar to the last problem. So again, you may want to pause the video, but it's very similar, but this would be the exact answer. All right, so find the exact value again of this expression. So we have all of this, and what we want to do is find the exact value of that. And so we're going to look at our common formulas that we know. So if I flip back just real quick, if you notice that common formulas, notice how this one, like the formulas for cosine are cosine, cosine, sine, sine. But here the sine, the formulas for sine, you have sine, cosine, cosine, sine. And so what we're going to do is literally just write that, use this, the formulas for sine. And notice the two angles are 20 and 40. All right, so those are my two angles that I'm going to be using. So this is literally sine of 20 cosine of 40 plus cosine of 20 and sine of 40. All right, and then what we want to do, that's the same thing as sine of 20 plus 40. That's literally what the sum of the sine formula says, which is the sine of 60 degrees. And we know the sine of 60 degrees, which is square root of 3 over 2. All right, so let's prove the cofunction identity cosine pi over 2 minus u equals sine of u. So we're just proving that this is true. And again, a cofunction is basically it's a function that is basically phase different. Like the cosine and sine functions, if you look at the graphs of them, they are very similar graphs. They're just phased over from one another. So a cosine and sine are literally cofunctions of each other. So what we're going to prove is this function identity is actually true. And as I said earlier, we normally start with one of the sides, and we're going to prove it equal the other side. We normally start with the more complicated side, so we're going to start with this. And again, if you go back to the cosine, the difference of cosine angles, you're going to use that fact, and then we're going to prove that that's the sine of theta, or of u. All right, so notice we use that, the cosine formula, and notice we're just going to evaluate each one of these. So cosine pi over 2, think of the unit circle, pi over 2, and so pi over 2 is right here, and then this is the point 0, 1, and so cosine pi over 2 is 0, and then 0 times cosine of u. Again, this is going to just all be 0, and then sine pi over 2 is just 1. So again, we prove the identity is true by making sure that we understood that the sum of cosine formula. All right, and then we have this one. And again, notice this is, as soon as I see this, I'm doing the sum of two angles for the tangent, and I'm going to be using this formula. So this literally is just following this formula. So we got the tan of pi over 4 plus the tan of x, and that's over 1 minus tan pi over 4 times tan of x. Now again, pi over 4, if you think on the unit circle, pi over 4 is square root of 2 over 2, square root of 2 over 2, and the tangent of that is sine over cosine. So tangent of pi over 4 is 1. So we're literally just going to replace this and this with 1. So 1 plus tan of x, and then 1 minus tan of x, and notice I proved it. So it's actually very simple. You just had to make sure you use the formula. All right, so let's look at our last example. So notice this, it says evaluate this. Theta of, notice we have two angles added together with the sine. So that literally is, we're going to evaluate those in the exact quadrant where they're talking about. So if we talk about sine in quadrant 2, so we're talking about quadrant 2 triangle, and the sine of this is, opposite over hypotenuse, so 12/13. That's what that's referring to. And then we draw tangent of theta in quadrant 3. So tangent is opposite over adjacent, so this would be 3 over 4. So now what it wants us to do is to consider So these are the reference angles. We're going to consider the triangles. Using the Pythagorean theorem, we're going to get -5 for that side. And to keep in mind, it is in the second quadrant. That's why it's a -5. And then you looking at this would be 3, 4, 5. Notice those are negative because it's in the third quadrant. So again, even though this is 3/4, it's in the third quadrant. So this point, is literally like negative. So you have to realize what quadrant it's in. Now, notice the sign, this right here, what we're referring to. So notice the formula. The formula for the sum of sines is that right there. And notice this is your theta. This is the other angle that we're referring to. Okay, so there are two different types of angles. Notice the two different ones at the very beginning. Okay, so the sine, sine of theta right here, opposite over hypotenuse would be 12/13. Then cosine of this one, so come over here and do cosine, so that would be -4/5. Cosine of theta, adjacent over hypotenuse, would be -5/13. And then sine of this, opposite over hypotenuse. So I evaluated each one. So think of this as like triangle 1 and triangle 2, and that's what I'm literally evaluating each of those functions in that case. So then all we're going to do is simplify this. So notice we didn't really need a calculator to evaluate any of these functions. We basically just need to know the sum of you need to know all the formulas for the sum of the angles for the sine, cosine, tangent, and we evaluated each one of those functions and finding the exact values of every